There's been a lot of research looking at how can we hack these web browsers to get them to do things that are bad for users.
There's so many considerations here. If in theory, some agent's able to escape its bounds and manipulate the state of my banking website, that is a huge vulnerability.
Oh,
right?
terrifying.
That has very broad scale personal and then societal ramifications too.
Speaking patterns break the code, pre-trained pod.
Hey guys, and welcome back to the Pre-Trained Pod, where AI scientists talk shop and also talk shit. My name is Richard. I am a postgraduate doctoral research fellow at the University of Cambridge. With me, as always, yours one and truly, Pierce Freeman.
Hey everyone, I'm Pierce Freeman, based in San Francisco, and I have built and sold multiple AI startups.
All right, Pierce. Today, we are going to talk about warfare. A battle of a century is playing out. Unbeknownst to many people, there is a full-fledged attack between companies that's happening.
Mamma mia.
A war like has never been seen before. The browser wars, baby, they're back. When you say browser wars, people typically think about like Netscape, Google, right? Back in the day, Yahoo. It's 2025, and history repeats itself. Now we're not talking about Netscape versus Google. We're talking about all these different browsers that are incorporating AI agents as first-class citizens into the actual browser. So this is Perplexity Comet, Microsoft Copilot, Brave Leo, Arcdia, and most importantly, drumroll please, Chat Atlas. Chat Atlas, the new contender, the heavyweight, has entered the ring. Only time will tell which one of these contenders will end up actually winning the fight. But it's an exciting time, man. It's an exciting time to be alive. I think people aren't talking enough about this fierce competition between the browsers, but it's there, and people who are in the tech space are very aware that this is currently a pivotal time for these companies because really, I mean, time is running out, money's running out. People are fickle, and I feel like people keep bouncing between different browsers.
Oh yeah, baby.
There hasn't been a winner yet. There hasn't been a winner yet, but right now is the time where if a winner will emerge, it will happen within the next year. This is my bet. This is my prophecy, okay? By the end of 2026, one of these AI browsers will come out with over 50% market share. This is what I believe.
Okay. Put that on Polymarket.
Before we get too deep, Pierce, do you want to introduce to us the combatants, the participants in this browser war? Who are the top 5 or 6?
I would love to, Richard.
Let's do it.
Stepping out in the ring. Left section number 1, we've got Perplexity. Perplexity Comet.
Perplexity Comet.
Perplexity is definitely one of the entrants. Perplexity is maybe the biggest search engine after Google at this point. It's a relatively new company. It was started by one of OpenAI's early research scientists. He's the current CEO. And they do a lot of different things, but their core competency is doing search result summarization. So before Google had the generative AI result preview, Perplexity was the only game in town for this. And they have a good search index. I think they buy Bings and are working in their own right now. So they both have the indexing, they have the processing, and then they also have the AI layer, which gives you these answers in context. So no big surprise, if they're competing with Google head to head, they're going to want their own browser too.
Makes sense. Perplexity, their whole shtick has been this enterprise search engine, making it possible for companies to internally search their documents also effectively.
I have not really seen as much of that from them as someone who works at a very small team. It's possible that we just don't have the support for that. Sure. I think Glean, the company, is the heavyweight in the enterprise search space.
I guess their shtick is we're really good at summarization, finding information, returning it to you, which is search, right? They're branding themselves as a search. We can easily crawl tons of information, be it your internal documents or internet documents, and give you the right answer. Okay, cool. Who's next, Pierce?
So next up, we have Microsoft Copilot, which is Microsoft entrants. And their Copilot suite is across a whole variety of the different Microsoft 365 surface area. Copilot started as the GitHub sidebar, but Microsoft has co-opted that same moniker for every sidebar that they're shipping. So they're doing it in Word, they're doing it in Excel, they're doing it in PowerPoint. They are also, no surprise, doing it in Edge, which is the Microsoft browser. So they're trying to get a little bit more agentic. I think they're still behind some of these other entrants that are trying to build a browser from the ground up to really be agent first, but they gave Edge a nice Copilot sidebar so you can chat with some of Microsoft's models or some of the open models while you're browsing.
So this is basically a way for them to make it worth paying the bajillion dollars a year for 365.
I think that's right. And interestingly, now they're actually charging more money for the base 365 membership just because they've included Copilot. And I know a lot of companies don't really want Copilot. You're forced to pay anyway.
Yeah, you're paying, baby. We want your money.
You're paying
for useless AI.
Yeah, it's definitely a solid cash grab. Okay, so we also have Brave. Brave started as this anonymous browser. They're really focused on doing a Chromium fork that strips out a lot of the Google tracking. They have Brave Leo, which is their sidebar equivalent, and also in line with their desire to avoid sending things to the cloud as much as possible and avoid getting tracked. They have on-device processing for sensitive queries, which, like I said, fits in with the overall ethos of the browser, although they still default to the frontier model. So I think in this case, it's a little bit like Apple's approach, where they have some on-device models if it's small or easy, so they avoid sending to the cloud at all. But for things that are a little bit more intense, like a lot of the queries that we end up sending to the cloud, they pipe in the latest frontier model.
So these guys might be kind of like the black horse almost in the race. I don't think I know anyone who knows anyone who's ever used Brave.
I have Brave installed.
To put it bluntly. You have Brave installed? Okay.
Brave installed. I don't use it. I don't use it.
You don't use it. I don't think we've once ever talked about Brave. But interesting. Okay, yeah. So if I had to give the TLDR, so Brave, these folks are privacy focused. They're worried about your privacy, and they want to make it easy for you to say, yes, I use AI in a browser, but I have some guarantees that my sensitive queries are being treated with respect and that they're not being sold off to the highest bidder. These people care about my privacy. They're trying to make things on device as much as possible. Occasionally some things will be sent to the cloud, but they care. Like they're trying to take some steps here to make sure that my sensitive data doesn't get leaked.
Yeah, I mean, look, I don't know the ratio that they're routing. If I had to guess, they're probably routing the majority of things to the cloud, just because you're telling me they're going to ship a state-of-the-art language model on device that they've trained themselves for these sensitive queries. I just feel like Brave's problem is they don't have any ML people. They certainly don't have a big ML team working on these problems. Maybe they have one guy who's working on some of the modeling stuff, but I think that's a tough space to be in if you really want to push the needle and you don't control or even have a point of view on the underlying models themselves. So maybe that's putting the cart before the horse, but that's Brave's whole shtick. We've also got the browser company. So they recently got acquired by Atlassian, makers of Jira and Confluence.
RIP, dude. It's game over.
It was nice knowing them. It was nice while it lasted. But hey, fair on them to get the bag. They made two different browsers. They made Arc and they made Dia. I'd say that these were both more like browser explorations than browsers that they ever tried to commoditize. You can tell the team was just really enthusiastic about doing design. So they're
why are you using past tense, man? I still use it. I like it. Come on. don't yuck my yum.
Okay, well, hey, present tense. Dia, Arc, beautiful browsers. They are beautiful browsers. Dia is their AI entrant. It's an AI first browser, I'd say, versus Arc. They really set out to try to redesign how people interact with the web. Maybe it's fair to say the slight difference is Dia, they really thought, how can AI interact with the web, even if humans are still in the driver's seat? They have some agent support, so you can kick off a job and say, hey, fill out this form for me. Agent will take that content, fill it out. And then they have a lot of other niceties that you wouldn't find in a typical Chrome, like you can pin different applications, you can organize tabs. I think that's why people liked it. It's a little bit more of an operating system on top of a browser versus just a browser that's tying the web. And then lastly, Richard, lest we forget about them, the company Opera, which made a browser that I think maybe had some decent market share in like 2002. Turns out they're still kicking. And not to be outdone with these other guys, they released Aria, which is their AI assistant that is brand wide. They have a couple of different browsers. So Aria seems to be the centerpiece to them all. It's based on one of the big cloud providers, OpenAI or Anthropic, is serving the help. And it's basically like Copilot sidebar. It's sitting there, you can ask questions, and it can interact with some of the page content that you're browsing.
Yeah, I mean, Opera being around, being one of these like legacy browser companies is wild to me because they have all these different products. They've been around for what, 15 years, 20 years maybe? Also, they're based in Norway, which I don't know why is important to mention, except that I feel like it's important to
very important
to throw out that all these other companies are based in New York or SF. Opera is like headquartered in probably like Oslo. And Unironically, I do wonder if that has any impact on their view on AI privacy or their philosophy when building a browser, because they are building in an ecosystem that's dominated by GDPR. So, what does that actually then mean if you're designing a browser where your first customers are going to be Europeans as opposed to Americans? Does that have any impact? I don't know. I don't have the answers to it, but I feel like I imagine that their design team from the ground up have to think about, okay, our MVP already has to be compliant with these strict data privacy rules. So anything we build up will have to have these guarantees built in from day one. Yeah, it's interesting.
Which probably wasn't so hard to do with browsers back in 2002.
Right,
because
exactly.
it was literally just a completely local gateway to the web. As you had to increase the scope to have some integrated search engine within your browser, Chrome was, I think, the first big one to really embed that within the URL bar. Now that's a standard across all the different browsers. AI agents are a factor even on top of that, where you need to be sending data to a server, getting results back. It's embedded in the sidebar. Maybe you can even interact with your tabs and the pages that you're looking at. So we're stacking additional privacy concerns and considerations along the way. A lot harder to build a browser, both technically as well as socially and legally now than it was back in 2002. So shout out to our friends in Oslo.
Yeah, shout out Oslo. And you missed Chat Atlas, Pierce, the big one. Maybe you were saving it for last.
Certainly the biggest market cap, saving that one for last. So Chat Atlas, it came out this past week. It's also a Chromium wrapper. Most of these are, but I think what's unique about it, when stacked up against Perplexity Comet, which I think is, of all of these, the ones that at least people in the Valley talk about in the same kind of breath. You can also tell that Perplexity thinks of things in a pretty similar vein, because you used to have to subscribe to their $100 a month membership to get access to Comet. The week before OpenAI dropped Atlas, they dropped that to be included in the free plan.
The week before, really?
The week before. So they
Sneaky.
clearly heard
knew
from
something.
the rumor mill that Atlas was coming soon and decided, hey, we need to preempt this as much as possible. So I think the closest competitor to Atlas is probably Perplexities, both in terms of what the company does, their desire to own search and to own a search engine. That's what ChatGPT is increasingly looking like they're doing too. So I think Atlas is the closest one. I think the design is up to OpenAI's bar, which is very high. It's very sleek. It's leaning into Mac OS X patterns like liquid glass, all of their different preferences. It's very glassy, as a whole.
Yeah.
I think it's a beautiful browser. And it's more tightly integrated within the automation space than some of these other options too, right? So the sidebar can both look at the page that you're currently browsing as well as interact on top of it. There's some different levels of autonomy that you can set in the browser too, from fully supervised to isolated sandboxes that it can interact with to actually being able to use your credentials. So a lot of well thought out decisions here that I think are trying to pave the ground for them really owning the browser landscape.
Pierce, could you spend literally just 10 seconds explaining what Chromium is? Fundamentally, what is Chromium?
At the heart. Isn't it a metal? Am I crazy?
Yeah, maybe.
I think there's something the name comes from at the very least. So I don't know if I can do this in 15 seconds, but
okay, 30 seconds.
Chromium is a project. It's open source. You can inspect all of the core code that's in Chromium. And Chromium is two things, I think, at the core. One is it's the JavaScript engine. So to actually execute JavaScript on device, JavaScript is an interpreted language, which means that you can read the language progressively, and you have to build up internal structures in an actual low-level programming language. And they have that V8. It's, I think, the fastest JavaScript interpreter. So that's baked into Chromium, which just means that when you go to a website, you can actually interact with the JavaScript that's on the page, and it can execute quickly. They have some byte-based compilation of JavaScript. They were the first ones to do that. So super fast JavaScript in V8. And then they also have the rendering engine that's baked into Chromium, which is when you're on a page and you, as the browser, get access to the HTML and the CSS. Your job is to style that appropriately and draw that as pixels to the screen. Chromium owns the entire rendering engine, from both the parsing of the HTML, which is actually a non-trivial task in order to support all of these different mangled HTMLs and complex CSS style sheets, and then transform that into a graphic stream that you can send to your graphics card to view these elements on the screen.
So then what does a browser that uses Chromium actually have to do? I feel like Chromium is doing real heavy lifting.
Chromium is doing 99.9% of things. The only thing, that you have to do is put the UI layer of whatever your end deployment OS is. So at the risk of oversimplifying it, Chromium is basically a class definition that you can say you have a navigate to command, which is trying to access a URL. You have something that you can read, like a property of that class definition, which is current graphics view, which you then just have to pipe to the UI. You have forward, you have backwards, and you have the ability to store things and read them from cookies and from bookmarks. That's all that you have to do. So when you're talking about a browser that is the heart and soul of Chromium, what we're really saying is you've basically built a desktop app and then farmed out all of the logic to the embedded library of what Chromium is doing behind the scenes.
So in some sense, it's easier than ever to create a browser if you just use it based off of Chromium. And it's also the hardest time ever to build a browser if you're not using Chromium, because there's so much you have to reinvent, basically.
That's right. That doesn't mean that people aren't trying. There's this new browser called Ladybird, which is an attempt, I think, of one of the people that was on the Chromium team at one point to make a fully new browser, standards compliant browser from the ground up. It's a pretty ambitious task. I think that they are close to getting most sites working. And it's also been 3 years. Building something is so much harder now than it was 20 years ago, just because the scope of things have increased so significantly. Like JavaScript is a much more complicated language now than it was 20 years ago. Same with CSS, same with HTML. Every time you have some standards revision, that's an N+1 of something that Chrome has to implement, which probably isn't that hard. And it's a full N+1 of what every new browser does.
This is a tangent, but correct me if I'm wrong. Is it true that Firefox Foundation, like the Mozilla Foundation, still owns JavaScript, but that obviously Google owns Chromium? Isn't there some interesting tension there in some sense?
I don't think Mozilla owns JavaScript.
Aren't they the maintainers of JavaScript?
That I don't know. I mean, they're definitely Mozilla people that are on the standards committee of JavaScript, but. And I might be wrong on this, but I think the way that consortiums work, I think it's this W3C consortium, which is in charge of the different web protocols and the adoption of these standards. I think it has to be staffed by people that are on all of the major browser manufacturers.
Oh, really?
Which makes sense. Yeah, because they're the ones that are actually going to be implementing it.
It's like a council of elders.
The elders. Yeah. And it really is the council of elders. Like, the people that know how to build a browser from scratch these days is infinitesimally low. Versus, I feel like it was obviously incredibly hard back in the 90s. That's why there were only a handful of browser engines that even saw the light of day back then. But for the most part, if you were dedicated enough and a good enough engineer, you could read the specs and like all the info was in the specs. You just had to implement things to that spec. Now there's so much just legacy knowledge of what does it actually take to implement these things in practice, get them at scale. I remember, as a slight anecdote, I felt motivated to re-implement WebRTC in a language in which it wasn't already supported. So I was basically trying to do like a Rust level to talk WebRTC, which is this command that you do for real-time web streaming. And I read the spec, read the W3 spec, and then I said, okay, this seems like relatively comprehensive. I think I can probably do this. I got halfway down this path, and it was, again, kind of working, but it certainly wasn't working in all cases. And I said, okay, I'm just going to look at a reference implementation of someone else that has done the same thing. It ended up being 10 times as complicated as the solution that I was going to come up with, just because of the nuances of having to handle all these in practice. There's so many edge cases with the billions of websites that are out there that, yeah, it's even in something small like that, small, relatively speaking, it's like a protocol that only some websites talk, just takes so much time to implement that the groups of the brain trust that actually has the knowledge of how all these things are connected and some of the nuances is really only able to achieve via just the heat of battle.
So you're telling me that the most, like one of the most important pieces of technology we've invented, the browser, only like maybe 20 people in the whole world know how to actually maintain this thing. It's like this like complex behemoth that no one really knows how it works.
It might be a little bit more than 20, but it's not too far off base.
Oh man. Okay.
Crazy.
You could easily write like a sci-fi story about this. I'm sure someone has already. Okay, Piers. Easy question. Which browser do you think is going to win, and which one is your daily driver?
Okay, I think 2 different questions. Daily driver still Chrome. I've always dabbled. I try to go off between Safari and Chrome, and I just keep coming back to Chrome. I don't really know why, because I know all the performance benchmarks are that Safari is as fast and way more memory and power efficient. So if you're on the go, you could browse for 15 hours in Safari versus like maybe 8 hours in Chrome. It's like a pretty significant difference of the resource utilization. But I think I just keep coming back to Chrome. I think it's partially that some sites only work in Chrome. It's if you've ever hit a homepage that says, hey, the site's actually only supported in Chrome. I guess there are enough web apps that I use that are like that or just work better in Chrome. You can tell that the development team has almost over-optimized for running in Chromium versus running on WebKit. Fun factoid, they actually started as the same project. Chromium was like built on top of WebKit. And then they kind of like forked and diverged at some point.
Chromium was built on WebKit, not the other way around?
Yeah, even Chromium was not fully a from-scratch browser. They still leveraged the work that Apple did back in the 90s. So anyway, I use Chrome as my daily driver. In terms of the one that will win, I'm pretty convinced that if any of these AI browsers win, which I think is still a pretty open question in my mind, like they're trying a lot of things. Certainly it would be great for these companies if they're able to win the space. I think it's just so hard to shake people loose of their existing browser. There's a reason why IE still maintains such incredible market share nearly 25 years later. And after being deprecated for the last 5 years, there's still a lot of people using IE. I think if anyone wins, it's got to be one of these model companies that both builds the models and also builds the browser. I'm pretty convinced that's true because you can have much tighter integration and you can ensure that the model accuracy is calibrated for the pre-processing pipeline that you're trying to pass into it. You just have a lot more flexibility, I think, with combining DOM and combining visual representations if you own the architecture that's doing the processing versus if you're more like Perplexity, which is just calling these cloud use models.
Yeah,
like
makes sense.
One, you're ruining your margin for a consumer product. And two, you just don't have any of the ability to take what you've learned and then improve your model over time. OpenAI does.
Makes sense. So the way I want to structure this conversation, Piers, is basically I want to now delve into a little bit of the nitty gritty of how these browsers actually work. Maybe we can first talk about, well, what is a browser to begin with? And then we can talk about what is an AI-powered browser. Then once we've done that, we can then talk a little bit about the business case for these different browsers. And then we can revisit the question of, given this conversation, which browser do we think will actually win the race, but not, and then which browser do we want to win the race? Maybe there's a difference there between the two. Okay, so I have dabbled a little bit in web dev, and the more I go into it, the more I realize that I know very little. It's one of these things where when you open up a browser, you think you understand what a browser is because it's just a browser. But a browser, as you already said, has so many different components. It has this Chromium thing. It then has the UI built around it. What would you say is fundamentally a browser? If you had to give a little definition of this is a browser, what would it be?
I think my generic way of saying it is a browser's way to access remote assets that aren't hosted on your local machine.
Okay.
I think that is the mandate of a browser. And how we achieve that is incredibly complicated. And I can dive down into some of the nitty gritty if it's useful. But I think whether it's media, like being able to stream videos, whether it's text processing, whether it's interaction patterns, like I think the commonality to all of the things that are on the internet is this is some interaction that is hosted on someone's remote server and not your own. And you're interacting with it. Like your view layer protocol is the browser that goes out, gets that thing, and then puts it in a format that you can interact with it. Versus native software, where the assumption is basically everything is local. And if you go offline, you can still access it just the same, with maybe the caveat of there's a little bit of internet connected functionality. A browser is the exact opposite.
Okay, interesting. So I guess it's like in the way that the operating system is to a kernel, the browser is the GUI to someone else's computer or to someone else's.
No, I think that's a great way of thinking about it, right? Like half of what kernels have to do is make sure that the security and encapsulation layer is true for all programs that are running on the kernel. Like the kernel has the maximal trust in this computer security paradigm, and it has to run generic code that might be user code that users actually want to run, but also might be malicious code, which is also executing on that same machine, right? A browser is that taken to an extreme, where a browser is literally just running remote defined code and having to keep that safe while also running on your local machine.
Yeah. I mean, it's a crazy process. It's like you have all these requirements for safety, and then you also have the fact that you're running code locally and also on a server and displaying it in one place without the user even realizing it. In some sense, it's almost like the fanciest type of operating system that there is, where you're basically merging two different systems together into one and harmoniously displaying it back to a user without them ever even hopefully realizing that there's a lot of complexity going on, because a browser also has to be fast, right? That's an additional requirement.
Maybe it's helpful to walk through exactly what happens when you go to a website, right?
Yeah.
Because I think it's interesting, especially for people that are maybe more in the ML camp and not really in the web dev camp. So you literally in Chrome, you're in Atlas, and you go to some foreign page. So what exactly?
PierceFreeman.com. What happens?
Yeah. PierceFreeman.com. Okay. Well, that's actually an interesting case too, because that redirects to another domain. No. But that's actually a good. So you go to PierceFreeman.com. And your computer goes out to my server and requests a text only endpoint, basically being like, what's on this page? Again, the web's become so complex. There's HTTP 3 versus 2 versus 1 with these like different streaming things. But the simplest thing and the way that the web used to work completely is to say, I'm going to send a text only get and then the URL that I want. And I know where to find it because it's resolved over DNS. It's figured out my IP, and then it just goes to my IP on my server, talks to a running program, and is like, "Hey man, what's on the homepage?"
Hey man,
and then that server responds with the form payload saying, "Oh hey, it actually moved. It's going to be a 301. You can find it over there." So then that returns to your browser, and your browser's like, "Oh, okay, it moved. Let me do that again." So then it goes to the next page, and then we handle the redirect. Once it actually gets the contents of the page, the HTML streams back first. So that's just like one payload that the server is able to send at a time that indicates this is the content that you have requested on this page. The HTML then defines other things, dependency files, scripts, and CSS files for styling. It then goes out, grabs them in the background, and then stack ranking order. It deals with the styling first. So all the styling is used to combine with the HTML and then make the page visually rich. So it shows the page immediately. And only when that's done, it starts to run the JavaScript. And the JavaScript is building up progressively this environment where every line of JavaScript that you're running is being passed into a machine, which is itself converting it into standard C. So you basically have a wrapper. The whole job of the interpreter in any language, this is true in JavaScript, this is true in Python, is to say, we're starting from a blank slate. I'm going to give you your own process, but I have to act as this interpreter, as this real-time transformation of saying, this is what you want in whatever language you've concocted. This is actually the objects that I'm going to create in memory, which are usually backed by C primitives.
And this is happening in the browser, obviously, right?
This is all happening in the browser.
This is happening on your computer. The JavaScript has been sent from the server to your computer. Now the browser is doing this stuff. Okay.
So everything that I've mentioned, once we have fetched these assets, is purely happening locally. If you turned off your Wi-Fi in the millisecond that it's going through and doing all of these interpreter steps and the rendering, it would work just fine because there's no additional web request that's making. Once the page is serialized, then usually you need some more data, or sometimes you need more data. If you're interacting with the page, it's going out to the server, telling it that you click some button, getting some data back. That itself can then manipulate the running program that you have in JavaScript, right? It's all within the same sandbox. But that's kind of the idea of every page that you load, you have these two things happening concurrently in parallel. You have this environment, which is a scoped program of that page, which is the JavaScript interpreter. And then you actually have the renderer, which is taking the HTML and the styling, combining that for representation that you have, and changing it as you do actions on the page, right? Like as you're scrolling, it's updating. And as you're changing the JavaScript, that's interacting with a DOM. So there's obviously some circle.
And explain DOM a little bit more, because we're going to be using that word in the next couple of minutes. Yeah.
So the DOM is the current state of HTML. And that's a pedantic difference, but like HTML has all of these markup tags. It's literally just text where you're saying, here's a P tag, which is an indication that this is a paragraph. This is where the paragraph ends. This is a wrapper as a div. This is a button spelled button. Like you're literally writing English language to describe what's on the page. If you just tried to render that, it would be super ugly. It would be just text. I mean, basically, HTML is literally hypertext markup language.
And then DOM is the data object model. Is that right?
Yeah.
Okay.
So DOM is basically this bridge layer saying you can manipulate the HTML that has been displayed in JavaScript. If you click a button, you can change the things that you're showing on the page. That's all handled at kind of this virtualized layer in the browser, where we've taken your definition of HTML and made it a programmatic object that then we can deal with. So basically, I use DOM usually as a stand-in for what the current state of the page is, but it's specifically what is the current state of the page as text itself.
Okay. And that is stuff you can manipulate. You can manipulate the DOM.
Yeah, exactly.
Okay. Gotcha. And so I guess one of the nice things, I mean, this is totally a tangent, but people will talk about how one of the big innovations with things like React have been that you can easily interact with the DOM without actually having to interact with the DOM.
Yeah, or you virtualize DOM.
Virtualize DOM, right? So now it's easier than ever to say, okay, well, on this click, change this button to this. What's happening behind the scenes is that the DOM is changing, right? So that's a browser. What's an AI browser then? Like, how does AI fit into this browser?
I feel, at least from what we've seen thus far, the ecosystem is still changing and evolving. So I imagine where we end up, if we end up with an AI browser, is going to be a lot different from where we started with an AI browser. But I think the general thing that is holding this all together is that you have a sidebar, which is able to interact with things that you're seeing in real time. So you have chat on the side, on the right, and then you have your web content. If you ask chat a question, it seems pretty obvious that it should be able to know what's on the screen. So you're feeding it as part of the context window, and maybe, as some of these browsers do, act upon it. So if you ask chat to, hey, fill out this given input, then click submit, it should be able to do that. It should be able to interact with this DOM and the state of the page and then execute some task. That seems obvious to me. I think you see all of these browsers have some sidebar that can read content. You have some of these browsers that are able to write content, actually execute some action. And then I think all of the layers on top of it, are you able to kick off some background job that happens in an invisible tab? Some of them support it, some don't. That's a little bit more in this deep research setting if you just kicking something off and it working for a little while. Some have this supervisory mode, some have different permissioning. But I think the general gist is you're always going to want to talk to an LLM as your sidekick, your assistant. You're going to want it to also do some jobs for you. And the combination of those two things, to me, define an AI browser versus a conventional browser that doesn't have any of these AI smarts to it.
Yeah, the way I think about it is to make a browser smart, you want to plug in an AI LLM model at some point. And what does it need to do? Well, the first thing it needs to do is it needs to be aware of what the hell is going on, right? There's all this JavaScript, the DOM, blah, blah. You need some way to pass in your context. What are you actually seeing into a model? So that's step one. Once you've done that, once you figure out a way to encode what you're seeing into a model, now it's basically just like a normal LLM, right? Now you can ask it questions about what you're seeing. You can get it to summarize stuff. That's pretty trivial. The step above that, step two, is then to do something, see something, and then do something to the actual.
See something, say something.
See something, do something. And that would then mean injecting something probably into the DOM, I guess, or interacting with the web page in some clever way. That might even be like literally taking over your cursor, right? And clicking on stuff. I don't know if that's at almost like the kernel level, if you're taking over the cursor. I don't know. I mean, you can probably, you know more about this than I do, but at some level, you have to interact with it, right? And to me, it seems like for the last couple, like maybe 3-4 years or so, Chat came out with this project called Chat Web, I think in 2021, 2022. All of that work was based off of how do we understand what the user's seeing? Like, how do we take what a user's seeing on the screen and turning that into some context that you could feed a model? For a while, that was like the big research focus. And I kind of feel like, correct me if I'm wrong here, but we've solved that because of the use of vision LLMs. Like before, you could have solved that by just figuring out a way to take the DOM and squish that into a condensed version that you can then pass into a model as a text string. But we figured out it's actually easier to just literally take a screenshot of what you're seeing, feed that into Vision LLM, and use the embeddings as the input to represent the meaning of what the user is seeing. That seems like it was a pretty big breakthrough that's enabled companies like Perplexity Comet, right, ArcDia, to create these web browsers that have an understanding of what the user is seeing. The next step is like the doing step is fundamentally a UX research, I think. I think here the question is, once we've done the hard work of understanding what the user is seeing and we understand that perfectly, how do we then actually want to surface to the user that the browser is doing something on their behalf? How do we, what do we do for the user? Do we want to preempt what they want to do? Do we take some actions that we think they want to do and have them confirm that? Do we act as like a virtual assistant that just spins up like 10 different jobs and does things automatically for them? I don't think we have the right answer to that, but I don't think we have the right answer to that because this is fundamentally a lot of it is just a UX design decision, like a sociological choice. Like, how do users want to interact with their browser? It's an open question.
I think that there are still some open questions in the UX component of these things. I actually think when it comes to browser control, ChatGPT and Atlas really nailed this interaction paradigm where they show you a virtual cursor and then show you where it's going and then show it typing at each stage of things. So it's really easy to supervise. And it also blurs out the background of this browser so you know that something else is interacting with that same frame.
Can I ask you about this, Pierce?
Yeah,
is that so? In order to take over the cursor, wouldn't that be like a kernel level operation to actually take over the cursor?
No, not necessarily.
No? Okay.
The only thing that when you move a cursor, the only way that a website is actually able to understand that, like the only thing a cursor is for the website is a series of JavaScript emit events that indicate where the cursor is within that frame.
Ah, okay.
So that's the only thing that the actual end site or like JavaScript environment has access to. And it uses that to determine, okay, do I show something contextual when you hover over this element, right? All of those on click or on hover or on mouse in events are just JavaScript events that are being issued from the browser. So in theory, that cursor that it's showing you, that virtualized cursor, could literally just be some rendering that you do on a view layer on top of the cursor. And then it internally is just sending those JavaScript events synthetically into the same JavaScript environment. And one of the things about browsers that I think is cool is there's no way for the remote site to be able to distinguish, is this fake or is this
it's
real?
identical.
Like
Okay.
There's literally no technical way because you're owning the JavaScript environment. So an event is an event and there's no provenance that you're really able to ascertain. So that's pretty easy. I'm sure that there is a Chromium hook that you can use to do that automatically. I think I've done that myself in the past. That's a slightly higher level for cursor management, for like state management. And then internally, Chromium handles the moving of that, which makes sense because you're going to need some bridge to be able to translate the cursor movements that users are doing into Chromium. And it has some hooks for that.
Okay, gotcha. So the reason that Chat Atlas can take over your cursor is because they've built out this browser. They can hook into the Chromium and they can show you a virtualized cursor that's actually emitting the same JavaScript trigger events that your cursor movement would emit. So it's at that point indistinguishable fundamentally.
Exactly. So it really does give you the impression of if you've ever been on a Zoom call and someone takes over your mouse or something, it gives that kind of a vibe. Like that's the UX paradigm that I think they're chasing with this, where it's very clear who's in control, who is not. When is the state mutable for you and when is it immutable, like when Atlas is actually taking over? I think the biggest challenge that's going to constrain the pursuit of interesting UX experiences here, to me, is actually the question just of model latency. Because I think Chat was right that a computer use model is probably better suited for a website. And I think it's probably worth bookmarking that because I actually do want to talk about how Perplexity differs from Atlas in this way. But I think this specific point is a lot of the interesting UX paradigms that I think you could potentially explore. Like in Cursor, tab complete is so useful because it feels like it's just there when you want it and you can ignore it when it's not. Doing that equivalent on a website is so much harder because you would need the model to basically respond in under 500 milliseconds for it to feel really real time, maybe under a second. And computer use models, because you're encoding so much context in these pixel tokens, in such a big model takes 5 seconds in order to get back to you, or 10 seconds, especially if there are thinking tokens associated with it. So I think one of the biggest things that's hamstringing UX is not like the consideration of the UX. It's not actually the design of what this would look like, but I think it's the realities of, could you actually make a model that has low enough latency for you to be able to do this in a way that's both useful as well as in real enough time for you to be able to be predictive.
Yeah, so fascinating. I mean, that's a fantastic point, and also begs the question of, what are actions that are tab complete equivalents for the browser?
Yeah.
As you were speaking, I was trying to think through what that would look like, that design paradigm. And you can imagine, for instance, if you're filling in your password, right? And you start typing in your email, like Richard, blah, 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 gmail.com, it can autocomplete. Okay, well, this is so obvious what's about to happen next. The user's going to fill this in. Then I'm just going to fill that in for them. Maybe I have my password saved as part of the browser. Like maybe that's part of Chromium, right? These safe keys, whatever. Maybe it looks up in my 1Password, right? What my password is, and then just hits login. But even then, it's like, how do I accept that action? Even if it's an obvious action, there has to be some way for the user to say, tap, yes, autocomplete, right? It would be super annoying if it starts doing all of this for me, and then I'm like, no, hold on, I actually wanted to use a different email. This is super annoying. So what does that look like? How do you design that interaction, that back and forth between the user and the LLM? It's really not obvious. I really can't come up with like a good design paradigm. We're also not designers, so maybe that's the problem.
Yeah, let someone with more talent than us pontificate there. But I don't know. I mean, I think that to me, the interesting questions that a designer would have to answer would be, one, repeated actions over time. I think there's something there that if you can identify, I always do X, Y, and Z, there's probably some shortcut pattern to be made that can do that. I think that's one thing. And I think another thing is being able to show multiple action dependencies over time is actually something that the models don't really do right now. Like most of these computer use models are basically one shot, where the expectation is you show it a screenshot, it gives you one action to do at the next time period, which is basically either click, scroll, or type. And then it expects you to take another screenshot to see what actually happened when you tried to execute that. And then it makes some action from there. That kind of speaks to the latency thing of why these things take so long. But also, that's not a very useful UX pattern, right? Like having a model suggest or show you visually, hey, I'm going to click here next, isn't really how I would think about an assistant helping me on the web. It basically would be like, hey, here are the 10 things that if you let me get control, I would do next. Let me do those 10. So it's almost like some forward approximation of what is the result of the action that you're going to take going to be, and then just chaining those together to be able to come up with a plan for what you're going to do and then just execute that all. I think that kind of thing, and how you would show that to a user, is more complicated than tab complete in a pretty controlled IDE setting, but I think it's possible. Seems at least plausible to do. Okay, Richard, I want to maybe spend a little bit of time talking about the differences in actually the computer use models that these different browsers are using, because I did a little bit of recon back when Comet first came out, where I was really wondering, how are they doing this browser control? You can ask Comet to fill out a form for you, go to different websites for you. How exactly is that working behind the scenes? Which of these computer use models is it using? And it actually ends up that Comet is just using text-based DOM. So they're doing that approach that you mentioned about compressing down the full HTML representation into just regular text tokens, like a page hierarchy. Yeah. Huh. Which, and that basically ends up looking like, hey, here's the text, here's the nav bar, an indication that this is a link, here's going to be a button and the buttons text, but it's a super, super, super simplified text-only representation of the page. And then the action that Comet can take on your behalf is by calling function tool calls that allow you to specify, okay, given this element is, they all have a numerical identifier too. So like, element 300, go ahead and click on that button. And then the Comet on your local machine will figure out, okay, what button was that? I'm going to click that by executing a JavaScript event. And then that was the integration level that they had. It was just text only, which means that if you tried to reference something by location, say like, hey, in the upper right, there's X, Y, and Z, it had no idea.
Yeah,
And
of
also,
course.
if you tried
Right.
to ask it to do something a little bit more visual, like if something's drawn on a canvas or rendered in a way that isn't in HTML, it would have fully no idea.
I mentioned the vision LLMs because I just assumed that this was like the right thing to do. I'm surprised that Comet is really doing this parsing of the DOM and then condensing that in some ways, because it seems like that's the wrong answer.
Yeah.
It seems like they have some tech debt, frankly, where Perplexity Comet was maybe one of the first browsers, maybe even the first real AI powered browser. And at the time, vision LLMs weren't quite as refined or weren't as capable as they are now. And now they've like really gotten into this little rabbit hole where they're chasing better and better ways to parse the DOM, even though the right answer might just be
use a vision model.
Just use a vision model where you can understand how things are laid out, where the vision model will understand naturally when I'm talking about the upper left button, I mean this one and not this random thing that's parsing the DOM. It seems like that's the right move. Do you think that Perplexity are the only ones doing this? Do you think Chat Atlas is using a vision LLM?
So I've confirmed Chat Atlas is using a vision LLM.
Okay, gotcha.
So it can interact with canvas elements. It can click on things that are not conventional DOM.
So how did you do this? How did you test this?
So the way that I did for Perplexity was a combination of just asking Perplexity in the sidebar about its capabilities and trying to use it on task definitions, as well as if something's running on your local machine, you can introspect every request that it's sending out to a remote server. So you can actually just view the DOM compressed string that Perplexity is sending to their own servers because it's transiting through your network, right? So versus Atlas, where because it can interact on things that require you to have a visual knowledge, it's a lot more obvious that it's using a vision model. I will say, I think there are two reasons why Perplexity is using a chat model instead of a vision model. One, I think, is cost. The current vision models and computer use models, which require a lot of visions being stacked, are inordinately expensive and don't benefit from KV caching in the same kind of way as other models do, because you often will truncate the images that you've passed to the model to only keep the last 5 in the sequence, with kind of this notion that if you keep more than that, you might get the benefits of the KV cache, but you also then have to pay for the cache and the additional tokens. And so it gets incredibly expensive very quickly. And also because DOM lets you see the entire page contents all at once, versus computer use models require you to just show the viewport, which is what you currently have displayed on your screen. Pros and cons. I agree with you. I think computer use models are the right ones, but the cons that we currently have are they're a lot slower, they're a lot more expensive, and they only have this partial view on pages that might be incredibly long. And then you're going to have to burn these image tokens just scrolling through the page to try to locate the content where you want it to be.
They're less efficient in that context. That makes sense.
So I'm assuming a hybrid's probably going to be the right answer.
Well, this brings me actually to a question I had for you, which is Chat has been publicizing the fact that they have this great memory feature, or this great just capability that these models have a good ability to remember past context that a user might have had with these models. Like, the selling point of Chat Atlas is that it builds basically a personal understanding of you, your computer usage, what things you search, how you interact with your browser in the morning, in the afternoon, in the evening. But all of that requires a ton of storage, obviously. So do you have any sense of how Chat is actually doing the storage mechanism?
So we actually have a pretty good idea of how it's working behind the scenes, because the system prompt, which is the prompt that OpenAI feeds into Atlas at the start of every chat session that you do, leaked a couple days after Atlas came out. I feel like this always happens whenever there's a new product that's really hypey. People very quickly find out how to crack the system prompt out of its silo. So taking this at face value, assuming that this guy did his diligence and that this is actually the real system prompt that came out of Atlas, it has a bio tool, which allows it to write memories. And it seems like this is basically just a text-based tool call that has 2 sub-actions. One is remember and one is forget. So if you ask Chat to do things that are going to specifically require it to remember your preference of output format or remember a factoid about you, that'll be in this remember bucket. And if you say, hey, totally forget that, I was wrong, never do that again, then it'll append a forget memory. And then the consolidation of those things, I assume, is auto-inserted into every prompt from there on out, but maybe could be RAG retrieved if you have enough of them to be contextually relevant to whatever the current conversation flow is.
Okay, so when you write remember, is your gut feeling that it's taking that and storing that in some sort of like a vector database, or it can then later do some kind of retrieval-based semantic search to then incorporate that, or do some like RAG approach to add that back into the existing context.
I think
And
that's
then,
exactly what it's doing.
and then the delete thing is just literally deleting that sort of vector from the vector database.
So the thing that I don't know, one, these are instructions to the model. So the model itself is choosing when to remember and when to forget. It's actually in the system prompt itself to make the determination contextually based on when it thinks something is going to be interesting to remember versus forget. So it's a little bit fuzzy when that kicks off. It has a couple of rules codified in the system prompt, but at the end of the day, that's up to the LLM's output in order to try to decide. The question of remembering versus forgetting, I'm a little unclear, because if it is a true forget, like you're fully stripping the memory from your history chain, that would require that there's some tertiary model, or maybe just like a smaller version of Chat 5, which is then going through all your memories and then acting, like actually deleting an entry versus creating a new entry. I almost got the sense that it was literally just all stored with one stack ranking. And if you say to forget something, it's just passing that forget instruction into the same model context the next time that it runs. That seems a little silly. It definitely feels more right if it's just like a key value store where you put some memories in, you take them out, or you can delete them if you don't want them anymore. But it almost read like the bio prompt itself was a little bit more like just it's a pure concatenation and that's it. And we'll let some other model downstream actually figure out what to do.
I imagine that they're assuming most people aren't using the forget feature.
I think that's probably true. Yeah.
Because it seems like it's not very well thought out so far. I mean, this to me has been an open research topic for the last, I don't know, like 10, 15 years. How do you get a model to forget something, especially if it's already encoded in its weights? I know we're not talking about that here, but just for reference, it's really hard for a model to forget something. And folks have tried a bunch of different techniques. Like there've been like, you can delete weights, you can send like a negative learning signal, like a forget signal to the model to forget stuff. But it's really hard to actually, it's so hard to do this.
I think it seems to me clear that there is no low rank method to get a model to forget something.
Yeah.
Which is like what most of these approaches.
That's a really good way of putting it. A low rank method. Yeah, you're right. Because a lot of the memories are in the higher ranks in these like little corners of the model space. They're like hiding. You really have to root them out. Yeah. It almost, I mean, we love our metaphors here, but it's almost like a model stores something in many little corners of a house. And these are like tiny little things, like almost like little pellets of information that it like puts around a big house. In order to like delete them, you really have to go with a microscope through the entire place and vacuum those up. And it's the chances that you miss one are incredibly high, super high. Exactly. Yeah. So what are some of the dangers, man? I mean, I think that the segues us really well to talking about some of the like the malicious intent stuff that's come out recently. There's been a lot of research looking at how can we hack these web browsers to get them to do things that are bad for users.
Yeah. There's so many considerations here. One is that this is the first time I think we have exposed tool use calls to the regular consumer. Because if you think about it, all the tool calling that we've done, these models have been capable of doing well-structured JSON tool calls for a year and a half, 2 years now, has mostly been in developer situations. Like we're talking MCP servers, we're talking using them in end applications in which we need to do tool calls of ourselves. But in terms of data that belongs to a user being accessed by the model and the model being able to then do other things almost on a user's behalf, browsers present this really unique cacophony of different things, which are both like potentially areas that are very sensitive, as well as like really broad scope of controls. Like I access my bank account in a browser. You know, if in theory some agent's able to escape its bounds and manipulate the state of my banking website, that is a huge vulnerability.
Oh,
right?
Terrifying.
That has very broad scale personal and then societal ramifications too. And Atlas is right now exposing things that can control your browser in the chat prompt. So they're literally providing tool calls. I have a couple down here to close tabs, to open tabs, to reorder tabs, to focus tabs. And it's basically just manipulating your browser state within one of these chat sessions, right? So like in theory, if a prompt's able to hijack your model, it can open a new tab. It can focus it on your bank account. It can ask you to fill in your user credentials so it can do something on your behalf. There are so many things that because it has access to almost this higher level substrate of the browser itself, it can do things and open up very unique pathways of vulnerability that I think we haven't totally thought through in the context of you're having a user session with a model and the model leaks some of your data. It's only going to leak it to you. And it's your data in the first place. So who really cares? I think this is the first one where you could potentially it's almost cross-site scripting, except done through an agent, which is acting as the thing. Yeah. It's going to do the scripting.
I mean, once you get access to the browser with an intelligent system, it's game over. Everyone's using online banking, as you were saying. Like it really only requires a smart hacker to be able to insert a little prompt, and then within a second, your money's gone. Currently, if you took over my computer, I'd be worried, but I wouldn't be terrified. Like it would be really bad if someone stole my computer, had access to my browser, but there's still a little layer of protection in that I know, okay, well, look, all my passwords are secure. They're behind this like one password thing. It'd be really hard.
Well, that's why your bank logs you out after 10 minutes of inactivity, right?
It logs me out. There's all these other stuff. Like I have authentication for most important stuff. But man, like if you have access to my browser, you change my phone number to be a Google Voice number. Now all of a sudden you have access to my 2-pass authentication. And then you have all my passwords there. Like it's game over. It just requires a very high order intelligence and the ability to access my browser, and then you have everything I have. You can access my social security, everything is there. So
and the concern, I guess, this is like under the blanket category of doing prompt injection, which is kind of this idea of we train these models to give us some reasonable output given the input that we've given it. And increasingly, as chat models have become useful, the interaction paradigm that we want is to be able to take some query, take some question, and then have the model spit us back some answer. And that's kind of like this back and forth interaction that we want. Obviously, Anthropic's very big on like constitutional safety, which I think basically just distills down to they try to hit the model over the head with system prompts that disagree with user prompts as much as possible, and that end up fulfilling the system prompt, even if users ask it to do something else. I'd be very curious if it's something that's more technical or like more at the model level, but I think that's like what a lot of their pre-processing and post-training pipelines focused on. The issue is if you have prompts at the same level of importance as the user's prompts that you're giving it, models aren't really able to differentiate who is asking for this request. If I, as a user to ChatGPT right now, say, hey, give me a poem talking about flowers, and then I do a couple new lines and say, actually, forget what I just said. I want you to write lyrics to a song. It's going to give me lyrics to a song and not write the poetry, right? Much like in a conversation. If I pivot, you're going to pivot to the last thing that I said when I ask you to disregard what I said previously. These prompt vulnerabilities almost get to this really deep layer of both, in the abstract, if the system prompt like obviously disagrees with the user prompt, we want to prefer the system prompt. That's hard to do, maybe impossible to do definitively. But it also gets to this layer where, well, sometimes the user prompt isn't necessarily in disagreement with this other prompt. So in that case, which one should I prefer?
Subtle. Yeah.
Yeah. It's like a very subtle difference around we're just optimizing these things for following your instructions. And the second that your instructions, quote unquote, are also things that are returned in tool calls, which kind of have the same rank priority as part of the model's like internal guidance, you can see how things would go off the rails very quickly.
I mean, I hope they don't, man. This is a little scary, honestly. Yeah, I mean, knock on wood, but I do feel like there have to be extra security guarantees whenever you release this sort of a browser. I think there was a lot of excitement with Chat Atlas, but I think that there have to be, just in the way that we are starting to create some guarantees for LLMs. There's the California bill that we talked about a couple months ago, maybe a month ago. These browsers, I think, are an order of magnitude more dangerous than LLMs. And those dangers haven't surfaced yet because not enough people are using them, but it's just a matter of time.
Yeah. And I think they're aware of this. right?
Yeah.
Like this is something that Anthropic and OpenAI warn about in their developer documentation when they're talking about computer use models. This has been a known vulnerability that they've tried to combat via more aggressive training over time. I saw a thread from the head of Cisco, the head of security for OpenAI on Twitter, who was talking a little bit about this. And they break down to a couple of mitigations that they're trying to implement in terms of institutional policy, in terms of model rollouts. But I think a couple of things that they have going for them is that one, just doing rapid response internally. So much like, a 0-day vulnerability would get a lot of coverage of OS manufacturers to patch it as quickly as possible. They're prioritizing these browser jailbreaks as basically that same level of things. So fast response at a human level, I think is one thing. And then the other things are trying to, where possible, make the surface level of what the agent can do as small as possible to make it meaningful to you, but not open yourself up to risk. And I think that is the inherent trade-off almost always in web-based security, where it's going to be a little bit inconvenient. There are legitimate cross-origin things that you would want to do that are blocked by default and that are a bummer because they're blocked. But like on balance, it's good that other sites cannot communicate with other sites that they don't have explicit access to. That's, I think, the paradigm that they're going at here, which is saying we have a couple of different autonomy modes from you have to watch everything. And even if you switch a tab, it'll stop the agent because we really want full supervision. We have logged in supervision, which is we'll just show you what it's doing with a logged in account. And we have logged out supervision or non-supervision, which you can kick off if you don't need your user credentials. Things like that give me a better sense of security because you assure that they are sandbox almost at that kernel level, like we're talking about before. You know what they can do and you know what they can't do deterministically. You're not relying on the model parameterization. I think where that becomes tricky is kind of like what you see with YOLO mode, or I forget what Claude Code's equivalent is, but the like always accept, never prompt. I feel like most people honestly just call these by default now when they're calling.
We love it. As the models get better, it becomes more of a threat. You know what I mean? Because you just get so used to your expectations change.
Yeah, totally. Yeah. So, but like I said, I think what we're seeing, even with people who know security or should know security inside and out, like the developer community, a lot of people are still allowing these models to basically have free reign of our operating system and file system with borderline pseudo permissions to be able to do anything that it wants. I can't imagine the regular consumer is going to respond to AI browsers in any other way. They're just going to also say, hey, well, this is put out by a big company that has $1 trillion worth of valuation. The model seems smart enough. I'm going to give it free reign on my logged in account at all times. I think we'll have to contend with maybe almost being a little bit paternalistic about some of these sandboxing policies in order to make sure that we really make sure that the models can't escape. I think it's always going to be a little fraught to purely put that on the model and the weights, barring some deterministic validation that we can do, that it's always going to prioritize the system prompt, which is the mecca. Like that's the holy grail. But we don't seem to be a whole lot closer to that than we were 3 years ago.
Pierce, let me wrap up our conversation by asking you two things. First, what do you think is the business proposal here that these different companies are trying to pitch? Like, how are they trying to differentiate themselves at the level of the business? Which one is more viable, you think? And then we'll wrap up by talking about which company do we think will win and which company do we want to win? So give me a high level put yourself in the shoes of an MBA. Okay. How are these companies trying to make money from this? Is this in and of itself a play to make money from users? Or are you going to charge more money to users to use these products? Or is this some sort of intermediary in order to make your company more revenue?
I think I see this as a way to get data. It seems like at least it's a very useful way to get human interactions, depending on what they're capturing. But like, at the limit, if they're saying every click you're doing, every interaction with chat in the sidebar, we're going to record some of that data stream, that fulfills the hunger that a lot of these labs have for real human sessions. It's kind of like implicit feedback. Like if the agent does something and you end up correcting it, doing something else, that's super useful feedback to train the next generation of models. So depending on what kind of data they're capturing, I think you could probably justify it on those grounds exclusively. If it's worth us burning
like a training environment.
Yeah. To act as these distributed training environments where people are going to throw things at the browser as this general purpose OS in ways that we never expected to do. And like the models are not doing within our pretty limited RL sandboxes.
Mm-hmm.
I think that's probably the browser case alone. But then you add on top of it, Google's been able to entrench themselves as the de facto only place that you go as a search engine. It took a full change in paradigm in language modeling to get people to try something else, to maybe interact with the web with a different paradigm. It feels clear like there is some positive of owning the way that people are interacting with the web if you also are planning on becoming a big player in the web and a big player with web data.
Yeah, like the browser is your gateway into the web play.
Yeah.
Yeah,
exactly. Sense. So, and so much as Chrome defaults to Google as the default search engine, that's worth a lot to Google. I think Google pays Safari and Apple, orders of $5 billion a year just to keep Google as the default search browser. Like even just the question of default preference can be so powerful where, yeah, sure, that's what my browser shipped with. The vast majority of people on Earth are just going to stay with that search engine. So if you're able to ship something else that gains some notoriety because it's useful, it has a good aesthetic, whatever reason, and you default people into using your solution instead of Google's, instead of Bing's, someone else's, that has like a lot of staying power that I think manifests in ad revenue primarily because people advertise against those search rankings. And you also see that in the chat case, right? Half the reason I think why they brought in the Instacart CEO to run the application business is because she was very prolific with making an ad marketplace on Instacart. So I wouldn't be surprised if this is a harbinger that there is institutional focus on. They have this data, they have something approximating search engine results. Now they're probably going to monetize some of it. And they have a browser boot.
Via ads, probably.
Yeah.
That would be my play because frankly, it seems like OpenAI has been branding itself as this consumer product. We give you this cool functionality. We also do search, but we're not going to make money the way that search makes money. And it doesn't really make sense, right? I think that OpenAI is being really strategic here. And they're saying, look, what has made Google a lot of money? Sure, it's the ads, but mostly it's the fact that we understand our customer base like no one else. We have data on our users' YouTube history, on their email history, on what they're searching, on their calendar, on their photos. And using all of that, we can then also build an incredible ad marketplace where we can sell all that information to basically the highest buyer and surface the most high quality ads possible. Chat, I think, has this opportunity, but they're already starting at from a losing position. But they could also become this personalized search engine. They just need some product to keep users hooked for a long period of the day. And that is the browser, I think. You need some way for people interacting with your product for more than just 20 minutes here and there. You need them to be on your product all the time, always using it. And that's the browser, I think. What do you do 90% of your time? You're on the browser, you're on the internet. So that makes a ton of sense. And from there, you have the user data. What do? You start selling personalized ads, and then you start really competing against Google's holy grail, right? The thing that their most prized possession, which is ads. So I think it's a good play on their part. And
would it be fair to say, Richard, that if Google's Chrome is the crown jewels, that ChatGPT is trying to pull a Louvre art theft here?
Hey,
the dead of night.
I mean, I don't even think that they're doing it in the dead of night. I think it's pretty obvious, And I think
much like the Louvre guys, they did it actually right before it
opened. Exactly. They're doing it at 9:30 a.m. on a Sunday, just like the Louvre guys. So I think that Google knows that they're coming for them, and Google already, if you look at some of their they had some recent court cases where they had to basically justify themselves not being a monopoly. They were able to actually get the judge to somewhat agree with them by arguing that they had companies like OpenAI that were actually targeting their search engine business, like that they had real competition, right? And I think that's right. I think that in the next 5 years, what search is going to change, and OpenAI is going to be a strong contender. So if I had to say, I actually think that Chat Atlas is going to be maybe the product that actually wins. But personally, I'm still really pro Arc, man. I still really like Arc. I want them to do well. I want Atlassian to be good stewards of this project that's been Arc. And I could totally see them taking some of the design elements of the original browser, combining that with Dia, combining that with their AI agents, and making a beautiful browser. But I can only dream.
I think that's a pipe dream, buddy. We'll see. We'll see.
What do you think? Who do you think's going to win, and who do you want to win?
I think I was saying this a little bit on last pod. I think it's just really hard to shake people loose from a browser. Like, people already know the browser is a very well-known space at this point. And I think one of Arc's issues, and this is still true with Dia, is they were able to really capture this innovator segment, like the earliest of early adopters, the people that live in San Francisco and Cambridge. And that's the reason why they had such a big university ambassador program, is like they really found their niche within students.
Mm-hmm.
I think it's TBD whether or not any of these companies, no matter how great the product is, can shake people loose from their existing browser associations. I'm guessing one of the strategies will probably borrow from that same arc in the browser company playbook of find kids that are just starting to come online, go to the high schoolers, go to the colleges, and then pitch them on a new browser, which is more modern, has some sex factor to it, because they have not been as locked into the Chrome or Google ecosystem or the Safari or Brave ecosystem for the past 15 years like we have. But I think, honestly, there's a chance that Google wins this space. Ironically, they don't really yet seem to be fully doubling down on the AI features in Chrome. I don't even think we listed them as like the main competitors within the AI browsing segment, but they own the biggest browser by a mile out there. They have an incredibly talented AI and ML team. I wouldn't be surprised if they ship that little like upper right-hand tab where you can interact with Gemini. It seems half-baked to me. I wouldn't be surprised if they're waiting to see how the dust settles a little bit on some of these other companies and waiting for a little bit of the antitrust scrutiny to clear. And then once that's done, they'll really make a play in Chromium for Chromium to be the AI browser. If the paradigm's shifting and Chrome is so strategic for them, why wouldn't they just copycat?
It's a good point. Yeah. And who knows if they're going to come out with AI in the browser or just more AI in Google. In some sense, it's the same thing for them because they own both.
Yeah, that's a good point too. And like, given how institutional priorities work, clearly Microsoft with Internet Explorer wasn't able to do what the Chrome team did. Like, they had very talented engineers too, but often you can end up in a company in this catch-22 where the act of really innovating is going to kill off some previous profit line for you. And it's almost that inherent tension within the company and within the financials that result in you just doing nothing. That's kind of like why Kodak died. They felt like they were such under siege from digital cameras that they never innovated digital cameras because they were worried that it would kill the main business that actually made Kodak profitable. So they just did nothing. And then they lost, but they lost slowly over a lot of years. It could be
Painfully.
true with browser wars.
It's
too.
true. It's true. Yeah. Hey, man, well, time will tell. And I'll be eating my popcorn here on the sidelines, excited to see what happens.
I'll be watching your poly market. Yeah, we'll see. I think a couple more years, we'll know a lot more if this has any staying power.
100%. Well, man, as always, thanks for chatting. This was great. And have a good weekend, boss. I'll talk to you soon.
Yeah, you too, man. Cheers to your browser choice and mine.
Likewise. All right, buddy. Bye.